welcome to my channel. It's been quite some time, and before we jump on to today's topic, I just want to take a moment to share something incredible that has happened recent. Couple of good news. First is we have hit the 10,000 subscribers milestone. We have crossed 10,000 subscribers on this channel, and that is not the only thing. I have recently got the opportunity to speak at GIDS, which is the Great International Developer Summit in Bangalore. My first time presenting at such a large scale conference like that. And I also got to present at the Java User Group Meetup in Bangalore. The first time speaking there as a Java developer, being a Java developer for 8 long years and speaking to the community in person. Both of these were firsts for me. And I believe that none of this would have been possible without the confidence that this channel has given me, all of you have given me. I just want to express my heartfelt thanks to each one of you who have subscribed to this channel, who have dropped their comments, who have shared my videos over these years. None of this would have been possible without the unwavering support that I have got from each one of you. So thank you so much. What I love the most about the community that we have been able to build, which is a mix of Java developers, backend, Spring Boot developers, system design enthusiasts, student developers, freelancers, this entire community that we have been able to build is so amazing. People who want to really go deeper into understanding the why behind everything. And that is what my motto of this channel has always been. Many of you already know that I don't always focus on the what and the how, but rather the why behind what we are doing. And I'm so happy to have been able to build this amazing community who also believe in this same. That is the kind of energy which fuels me to deliver these talks. So I recently gave these talks around building AI agents, the same playlist, which we are anyway going to do. So I think amazing. I think really good time, and I'm really excited and looking forward to doing more of this, what we have been doing. So now coming back to the topic that today, as part of the AI engineering for Java developers, we'll be doing deep dive around building AI agents with MCP. So in continuation to the series that we are going to do. So yeah, without further ado, let's dive right in. So this is the playlist which I was talking about, AI engineering for Java developers. Last we talked about tool calling and structured outputs. Before that, we talked about memory and RAG, and today we will talk about MCP. So a very quick recap of what we were doing and the why we were doing. So let me pull up that particular slide deck. These were the patterns which we were discussing. We started with the basic terminology. Then we talked about the roadmap of AI engineers who are, of course, Java and Spring Boot developers. And then one by one, like system prompt and structured outputs we covered because it is trying to solve this particular problem. So on left hand side, we have the challenge, we have the problem. Right hand side, we have the solution. So we covered till memory, RAG, and tool calling. Now we are left with MCP and skills. Skills will not be covered in this particular video, and it is a very small topic and not much of a concern. But MCP, let me tell you, it's like a really ocean. So you can dive deeper into it as much as you can. There is no end to this. But the point of model context protocol is right now there's a lot of noise around it still, and a lot of documentation, this and that. There is a humongous amount of information. So the goal of this particular video is for you to understand that as Java developers ourselves, we have been working with protocols like this earlier as well. When we were building REST APIs, we were doing this HTTP API calls. So let us try to draw the parallels between client-server architecture, and let us just try to see that if there is a Spring Boot application that you have, how can you simply convert that to an MCP server? And once that is a server, it will start serving. And your clients, how can you actually build your MCP client again from an existing particular code base? And then how this client and this server are going to communicate with each other over this particular protocol. So that is the main goal that we are trying to achieve from this particular video. So now let's go into the basics. Talking about MCP, I'm sure many of you have come across this particular website, which is modelcontextprotocol.io, which is like the original documentation of everything around MCP. And some of the basic things that we already know, this has been created by Anthropic, open source standard created by Anthropic. MCP is also known as the USB-C for AI applications because as we have seen from that particular deck, the AI applications earlier, if it had to connect to external systems, there was no means of doing that. And MCP being that protocol is trying to bridge that particular gap. So these are some of the basic things that we know, that the open source standard for connecting AI applications to external systems. But now the question is, what actually existed before MCP? What really led to the introduction of this particular? Because see, as Java developers, our work is, once we understand the basics of how this protocol works and what is the architecture, we can jump onto building our MCP client using the external MCP servers or creating MCP servers. I think as application developers, that is what our focus is. But it's always important to know what preceded before so that we can connect the dots. So we just learned about tool calling in the previous video. If you have not watched, I recommend you to watch this, because this particular video is also an extension of the code base of what we had worked upon. So we'll use the same code base and we'll extend that. So it's important for you to be in touch for the continuity. In the previous video, like we talked about the tool calling. So now let us also try to understand what actually led to the formation of this protocol. If you see this particular documentation, of course, a lot of important insights and everything is there, but I've tried to simplify this particular information. So let me take you to that. Before MCP, we learned about tools. Right? Your applications will not have access to real-time data. For example, very basic date time. So when earlier you were asking what date or time is it was not able to, because the model is being trained to a certain cutoff date, and obviously it cannot have access to latest date and time, location, latitude, anything real time. Weather. So when OpenAI introduced the function calling, these tools were defined as the JSON schemas in the API. And every app had to manually define, register, and handle these tool schemas, because tools, the functions, basically the functionality that we are exposing, it had to be handled for integrating in the application. Now, there are so many model providers and everyone having their own JSON schema for introducing that particular tool. And then every framework, now again, two more problems. Frameworks, there are different model providers having different schema. Then there are different frameworks which were having different annotations. And then the main issue, which is a design constraint, is when you have too many tools. Like also, if you go back to that particular GitHub repository and or see the video, we ended the video at a point where all the tools that were defined that existed. Like I said, it's a monolithic app. Like all the tools are now existing on the app. So for the sake of demo, for understanding, it is great. But is it great for a production level code base? No, because if anything has to be productionized, it has to have that separation of concern. Now, the tools were being tightly coupled to the app. So now as the number of functionality increased, number of tools increased, so that was getting tightly coupled to that in-house local app. And of course, the thing around reusability, right? So if you have multiple tools, had to be reused for different applications, same logic, it had to be copied. So a couple of things were happening in the world of the tools before actually MCP came. And another thing was this plugins for some moment, which it came, which was proprietary, and there was no ecosystem adoption. So all in all, these are the problems that were created. Interoperability, there was not there. We could not independently deploy. There was no tools discovery, duplication, no reusability. So pretty much if you see these problems, these are the problems which kind of happens if you do not have system design constructs in place. People who have been backend developers or architects would pretty much understand, these are the problems which anyway exists in any kind of system if you do not have interoperable standard. So with that, Anthropic released MCP as this open source, open standard protocol, calling it the USB-C for AI, or rather it's better to say USB-C for AI applications, where it will provide us the standard interface, the protocol, the bridge for connecting your AI models, building applications on top of these AI models to the tools and data which are available outside in the external systems, or rather connecting to external systems. It is language agnostic, framework agnostic. Any MCP client can talk to any MCP server. So these are the different capabilities that MCP standardizes. Like tool discovery, the client will ask what tools do you have, it will get it. So there is client and server picture also coming in. So the capabilities, tool discovery, tool invocation. Now all of this are now compartmentalized. So tools can be discovered, tools can be invoked. The transport system is now having 3 different transport type. This is transport agnostic. Resources and prompts, or any kind of resource, tools, prompts can now be externalized and the client can use it. So before, the app was embedding the tool, it was tightly coupled, not reusable. And later on, the app can discover tools from MCP servers. So we have this decoupling, reusability, and independently deployment. I mean, when we work with microservices, I think these are the things that we anyway look for. So very simple analogy is the USB-C. Why? Because standard tool protocol before and after. Now, before we move on to why it matters for Java or Spring AI, let me also take you to this particular page. That MCP follows a client-server architecture. So 3 things you have to understand: that there's a client, there's the server. So MCP servers are exposing the tools, resources, and prompts to the clients, and the clients, which are your AI applications, connecting to the server using the capability. Very simple. Like we'll see in like different steps. How can you convert a Spring Boot app to a server and a Spring Boot app to a MCP client? Very simple. And the communication happens via JSON RPC over different transports. However, streamable HTTP is the de facto or the recommended transport type as per the MCP spec. So these three things you have to remember as well when it comes to client server architecture. And now that we've discussed all of that, so what it means for you as a Java developer, or again, amid all the noise, what do you as a Java developer need to know or understand? So if you keep your mindset, or if you approach it with that mindset of how you approached when you moved from monolith to microservices, or how you essentially view microservices pattern as a pattern, then you will be able to relate to this protocol even more. So as I've written over here, that if you know how to work with Spring Boot REST controllers, you can build an MCP server. And if you have been working with Maven dependencies, you will anyway have an MCP client. It is as simple as that. So it's not like learning a new protocol from scratch, because it's anyway happening over HTTP. And then abstraction is done by Spring AI, so you already have that leverage as well. The only difference is now where the tool lives. So the tool which was earlier tightly coupled in your app, which will now act as the MCP client, we are going to move that to a different application or to a different service, whatever. Think of it as going from monolith to microservices, like I said, and you don't have to parse MCP messages, all of that. So a lot of abstraction anyway is there. Separation of concern or decoupling is anyway being given to you. And talking of the JSON RPC, that particular thing, let me also show you this. So technically, this is how this JSON RPC schema is going to look like. So you'll have whatever your name of the tool is, the arguments that you're passing. On one hand, you have the client, on one hand, you have the server. The schema is happening. This is the schema which is going to be passed. And if you see that earlier in the monolith, like I said, all the tools are inside the app. Then an MCP server is just that the tool method, the tools are in the separate app. Your chat client is calling it over HTTP via, and MCP client is now, how do I convert that to a client is basically we add a dependency and two lines of configs, and the tools get auto discovered. So pretty much these are the very basic important things which you have to know about MCP. These are the timeline summary. So now let me show you in 3 steps, how can you convert a Spring Boot application to an MCP server? Then we'll go into the code. So while I was presenting this at the Java user group meetup, so this is the tech from there. So 3 steps to build an MCP server is: 1, you add this particular Maven dependency. I'll show you where you can get all the different other Maven dependency, because this is the Flux or the reactive Maven dependency, but there are others as well. So first is add the dependency, think of it like that. Then you're configuring the transport, the protocol, the port. And third is you are now exposing the tool by annotating it. So in very 3 simple steps, we will build this particular MCP server. So what I'm going to do is, because I'm anyway continuing from the previous example, so I'm going to show you how the tools which were earlier in that particular initial project, we are now going to expose that and we are going to move that out. So I've already done the changes that we show you. And before that, let me also show you the documentation. So this is the MCP documentation on Spring, and how will you be able to find out where do we get the dependencies from? It is over here. So you see Spring AI MCP integration. So where are the starters? So these are the starters. So when we will add the MCP client, we'll use this. And the server starter, which I've just shown, I was probably using this one, right? Yeah, the web flux one. You can use the web MVC one. And these are all the properties and the starters. You can get it from this particular documentation. And of course, the annotations and everything. This video is not about a deep dive into everything about MCP and Spring AI, but at least a very important entry point into how you should work with MCP when you are building your AI agents. Time to do the code walkthrough. So starting with the pom.xml over here, as you can see, this is a completely new code base, which is different from the previous code base that you have seen. We'll go to that code base, but now we are focusing on that 3 steps to build an MCP server. So if you just scroll down over here, this is the dependency like we have just shown that we have added. Other dependencies, because in the previous code base, the unicorn booking or the rental thing that we were building, we were also trying to save the bookings in the database. For that reason, we have added all of these dependencies in the pom.xml, because all that functionality of booking, date time, pricing calculator, every functionality is now going to be inside this particular. This is what we have added in the pom.xml step number 1. Step number 2 is in the application properties, as you can see. Very basic ports and all is fine. This is the important thing. If you don't add this protocol, it will fall back to default the SSE, which is a server sent event. And because streamable HTTP is the de facto standard, it's good to stick to that. SSE might get deprecated. The problem with SSE is also that the connection will remain open all the time, not very network efficient. Now, these are the properties for the database thing. And yeah, pretty much same things. The only important thing is this protocol and this port that we have defined. Now, with that, if you see all these tools, the booking tools, date time tool, all the tools that we had, we have put it over here. This is the MCP server config that we have exposed, that in this tool callback provider, we are just passing. So these tools were earlier, we were passing in that particular application. I'll go to that application and show you the change as well. So over here, we have just added this configuration. And yeah, that is it. Everything else is just the business logic part of it. No matter how many models you have, no matter how many repositories you have, that is your business logic. But the bare bones thing is these are the setup that you need to do. Now, the interesting question is, okay, we have the server. Now we have to test it. So remember I told that I'll also show you the Postman equivalent of this particular MCP server if I have not said that before. So here we are. So we have to actually test this. How do we test it? So we have something called MCP inspector. What do? We have this npx. This is how you invoke the MCP inspector. It has a nice little UI which will open like this. So to select the transport type. So for us, it is streamable HTTP, which means everything is now going to be available at /MCP. This is the port number, and you click on connect. So you can see Unicorn MCP server, it now got connected. So what are the resources that we have over here? What are the resource templates? We don't have any resource or templates. What we have is we have the tools. So we'll click on list tools and you see all the tools are now available for you to test it out. So this is how when you're building your server, this is how you can test it. Not just tools, as I said, tools, resources, prompts, and there is also something very new now, which is called MCP apps. Very interesting, which will be covered, which will be available in this particular tab. So this is how, when you are actually creating your MCP app, this is how you test it. So now what we are going to next do is we are going to start this MCP server. But before we start this MCP server, it is important for us to go to the MCP client, that particular application which we are exposing as the MCP client. So let us do that first, and then we will start the server and see the connection between both of them. So just as we have seen the 3 steps to build an MCP server, let us also see the 3 steps to build an MCP client. So let's go over there. We'll definitely cover the steps to do that in the code. But just to give you that perspective, that step 1 is first the dependency, like we have added for MCP server. This is the dependency for it. I've already shown you the starters for client and server where you can get it. Step number 2 is in the application properties or YML. I prefer using application properties. So these are the things. Now, if you see tool callback enabled true is something which you have to make it true. And this client or name is something just an identifier, so that because if you have multiple MCP clients, just to segregate between that. And the third property is going to be your MCP server's URL. So ensure that right now it's in localhost, you're going to use your MCP server URL over here. So the basic application property changes. Now, third step is, as you might be familiar when we were adding the system prompt, advisor, the tools. So the before I have commented this line now, default tools, we were individually adding all the tools. Now instead of that, we'll just use MCP tools. I'll show you that in the code. And also it's no longer default tools, it's default tools callback, tool callbacks. So again, just to give you a perspective on 3 steps to build an MCP server, 3 steps to build your MCP client. So this is what the focus of this particular video is. So let's go to the code and let's try to check and test this out. As you can see in the pom.xml, this is the dependency we have added, application properties. So in the application properties, before pushing the code, I'm going to clean up all the unnecessary properties because we have anyway moved it now to the server. So we are going to move it there and keep only the ones that we need. And now this chat client config over here, as you can see, let me scroll a bit. So tool callback provider is the class that we are going to use over here, which will give us the instances for all the tools defined in the different sources. And now with that, we're using this particular variable and putting it in the default tool callback. Okay. And that is that. Nothing else changed. Everything else will remain the same. And we just have to now start the server. So let's start the server on the client. Let us also start the server on the server side. So what I also, okay, I think there is an exception. All right. So now as you can see, the client has started. And if I scroll up a little bit, how will you know if it has connected to the server is, as you can see over here, just try to highlight. Server response with protocol capabilities, blah, blah, tool capabilities. This is the name Unicorn MCP server because that is the name of the server, right? And similarly, even on the server side, you can check the same. And if I go over here, I can just highlight this a bit. We had given the name for this particular client, that Unicorn Rentals chat agent. So this is how you can see that the communication has been established between both. Now, the expectation is that now if I go to that particular interface from where we were anyway interacting, what we should see that this tool capabilities that we are exposing, we should be able to see logs over here. So let's try that out. I'll just ask what time is it now and where am I? So this is supposed to invoke the date time tool that we have exposed, and that should come in the server. The log should come in the server. So we didn't, in the tool, we had only exposed the logic for date and time and not for location. So this is what it is trying to say this and this. Now let me show you the logs on the server side. So as you can see on the server side, so starting execution of the tool, right? Client initialize the request, starting execution of the tool, successful tool execution, converting tool result to JSON. And if I come over here, it's just saying completed streaming response. But yeah, the main logs is this. So as you can see that the tool calling, which happened on the server side, and the client and the server are now communicating with each other. So yeah, with that, I think we are pretty much done with the scope of today's video. This is what the scope was. The code will be available in the description. Check that out, both the GitHub repos. And thank you so much for watching. Looking forward to all the people who are in and around Bangalore again to meet and greet, to celebrate this milestone together. I think we have never met in person, barring a few of them who I have met in some meetups or some conferences, except those. But I think as a community, we have never met together. So let's do that. I'm really looking forward to catching up with all the folks. And for the ones who are not in Bangalore or who will not be able to make it, I believe that if I go on other speaking engagements somewhere across India, I'll try to do this in real time meetup where I can have people from different parts of India. So yeah, with that, thank you so much for watching today's video, and I hope you got some value out of it. Looking forward to see you all in the next one. Bye bye. And